For today's lesson, we're going to look at combining all of our transformations. It's one of my favorite things because you get to see everything put together. So you will need lots of graph paper, and we're going to go through some examples together, okay? So to graph our function, so y equals a sine k theta, this is supposed to be, this is opposite, okay? So this is our d here, and then our c. It doesn't really matter. People have tons of different ways of saying this stuff, or we can look at graphing cosine, which is almost the same if you remember from the beginning, but very first lesson, but that's okay. We're going to apply our transformations in this order. So we're going to apply our horizontal stretch or compression first, horizontal translation or phase shift, left or right, then our vertical stretch or compression, a reflection about our x-axis, and then our vertical translation up or down. So I will show you that through lots of examples, okay? So you can copy out that slide, though, if you want to remember what we're going to do, okay? So we're going to go through 4 examples. Sorry, I was just looking through my notes. It's 4 examples together, and then it's going to be homework time, okay? These will take a little bit longer, but it's putting everything together, which is good for you to understand, okay? So we're going to graph each of the following trig functions. We're going to use an appropriate scale. We're going to state our amplitude, our period, our phase shift, and our equation of our axes. We're going to state 2 coordinates of 2 zeros, 2 maximum points, and 2 minimum points. So with looking at an equation, we can do our amplitude, our period, our phase shift, and our equation of our axes. We're going to want to wait to state those coordinates, which I'll show you in the next slide. There's our graph once we get there. But we're going to wait to state our zeros, our maximums, and our minimums once we see our graph. Okay, so to start, we can look at our amplitude. Remember, our amplitude is that a value out front, which is 3 all over 2, which is just 1.5 if you want to put it that way. Okay. Our period is going to be affected by our k, so we're going to take our 360 degrees and divide it by 4. 360 divided by 4 is 90 degrees, so our our period is 90 degrees, okay? We have no phase shift, so you can just put no, not applicable because we don't have anything in brackets there. We don't have a d value. And then our equation of our axes, remember, we don't have a c value either, but we don't put not applicable for that. We have to put y equals 0. It still stays the same, so our middle of our graph is going to be at 0, okay? So what I want you to do is we're going to actually apply all these in a table of values, and then that's going to be what we're going to use to graph, okay? So 0, 90, 180, 270, 360, then 0, 1, 0, negative 1, 0. Okay, so let's look at our amplitude first. Our amplitude is going to affect our y values, because remember, amplitude is pulling our graph up and down. Up and down is our y values, so we're going to multiply all of our y values by 1.5. Okay, so you're going to multiply each by 1.5. Pretty easy math there when you have zeros and ones, okay? And then we are going to take our x values. Remember, our period is our how wide our graph is. So normally it's 0 to 360 degrees, but we are dividing that by 4. So we're going to take each of our values here and divide each point by 4. So 0, 90 divided by 4 is 22.5. 180 divided by 4 is 45 degrees. 270 is 67.5. And then 360, divided by 4 is 90. Okay, so you're going to get new points that are going to be 0, 0, 22.5, 1.5. These look like 8s. They should be zeros. 45, 0, 67.5, negative 1.5, and then 90, 0. Don't round these. I know that it'll be tempting to round those to like 23 degrees and 68. Don't round them in your table of values, okay? Keep them as what you see on your calculator. So I'm going to go to the next slide. this is just our final. Those are the points that I just wrote down, okay? Those are the final points. So we're going to go ahead and graph them. So 0, 0. Then you're going to go halfway between 45 with 22.5 degrees up to 1.5, over to 45 degrees and go to 0, over to halfway between 45 and 90, which is 67.5, down 1.5, and then back up to 0. And you could actually keep going. You could go 90 plus another 22.5 up to 1.5, and then you could keep the pattern going. This is from Desmos. Okay, so then you're going to graph. Woo! Much neater. Much neater. Nope, that's terrible. I have to erase that. Okay, you're going to graph a lot neater than I can graph on this whiteboard. Okay, and then from looking at that, we are able to state our zeros. Remember, zeros are x-intercepts. So 2 maximum and 2 minimum points. So zeros, it doesn't matter which 2 you state. Your easiest one to state is 0, 0. There's one of your points that goes through. And then another 0 is 45, 0. Okay? If you were to graph only one cycle, you are only going to see one maximum point. So you're going to have to continue your pattern on to see another maximum point. Okay, so you have one maximum point at 22.5 degrees and 1.5. And then you also have to continue on. You're just going to go 90 plus 22.5, so 112.5 and 1.5, okay? Because you're going up, each of these is going up by 22.5. That's how you can tell this is plus 22.5, okay? Minimums, again, if you only graph one cycle, you only see one minimum. So you're going to have to graph another cycle to see a second minimum, okay? So 45, and we went over to 67.5, and we went down 1.5 to our minimum point. And then again, all you're going to do is go 135 plus 22.5 to get you to 157.5. And then down to negative 1.5 is your next minimum, okay? So this would be a max, a min, and a min. And then for x-intercepts, you have four choices technically on our graph. It doesn't matter which two, actually 5 choices, sorry, which ones you choose. You just get to state that for me, okay? So that's our first example, and this is what you should be able to do now combining all of our transformations, okay? So make sure you have that copied out, and we'll go on to our next one. Okay, this time we are looking at y equals negative 2 cos. Make sure you see that it is cos, not sine, and x minus 30 degrees, okay? So our amplitude here is going to be 2, and then you just have to remember that there is also a reflection in the x-axis. That's what that negative sign is, okay? Our period, we don't have a k value, so our period is just 360 degrees. Our phase shift is from this negative 30, but it's going to be plus 30 degrees, or you need to write right 30 degrees. Okay, and our equation of our axis, we don't have a c value again, so it's just going to be at y equals 0. Okay, so you need to be able to tell all of those from your equation. Okay, now what I would like you to do is to write out your table of values. The 0, 90, 180, 270, and 360 don't change for this, but your cos or your y values do for cosine. Okay, so it actually is just going to be 1, 0, negative 1, 0, 1. Okay, so this is for cos and not sine. Okay, so those change. Just make sure that you are changing that when you see cosine. You just have to pay lots of attention there, and so you don't do sine or you won't get the right graph. Okay, so again, amplitude affects our our y's because it's going to stretch us vertically up or down. And then you can, at the same time, do the reflection. So we can just multiply everything by -2. That's fine. You can combine them, okay? So you're going to do 1 times -2, 0 times -2, -1 times -2 is +2, 0, -2. Okay, our period is 360 degrees, so we don't have to do anything to our period. Nothing's going to affect those x's and stretch or compress them, okay? So just leave that. Our phase shift, though, we're moving to the right 30, which does affect our x values. So we're going to have to add 30 degrees to each of these. Okay, and then equation of our axes doesn't affect our values at all either. So you're going to get 30 -2, 120, 0, 210, 2, 300, 0, and 390, -2. Okay, so that is what you're going to get for those. I'm going to go on to the next screen. Okay, there's our final table of values so that we know for graphing. Okay, and then we're going to be able to state some maxes and some mins and our zeros. Okay, so we're going to go over, we're going to graph 0 and go down to -2. Then you're going to go over to 120 and stay at 0. Then you're going to go over to 210 and go up to 2. Then you're going to go to 300, stay at 0. And then you're going to go to 390 and go down to -2, and then you connect your dots there. Okay, again, we have 2 minimums from our graph, but we only have 1 maximum. So each of these is going up by 90. So 390 plus 90 is 480, and you'd be back up at 0, your equation of your axes. Okay, and then you can add another 90, go up to 570, and go back up to your max, which is 2. Okay, so that will give you another maximum. Okay, you might have to extend your graph, which it's good practice to be able to see that, just going up by 90 degrees, and these don't change, right? Your maximum and your equation of your axes, so it's just either up or down to 2 or stay at 0, just following your pattern. Okay, so your zeros, you have 3 to choose from, so let's go 120 and 0 is 1, and then 300 and 0 is another one. It doesn't really matter. You can also, if you want, put this 480 and 0 as well. It's up to you. Maximum is going to be 210 and 2. Or go over to your other maximum that you just graphed, 570 and 2. Okay, your minimums are going to be 30 and -2. And the other one is 390 and -2. Okay, so sometimes you do have to extend that graph to get that. So copy this out, make sure it's copied out, and then we'll go on to our next example. Okay, so we're back to a sine graph, so we don't see cosine. We're back to sine. We have no a value out front, so our amplitude is just going to be 1. Our period, this is nice and factored for us already, so we all only have to figure out our period by looking at our k value here. So you're going to take 360 and divide it by 2, so your period is going to be 180. Okay, so our x's are going to, we're going to have to shrink our graph. Our x's will be affected. Our phase shift is going to be opposite of what you see, so we're going to move ourselves left 45 degrees or write it as -45 degrees. And our equation of our axis, we finally have one. That is that +1 at the end, so it's going to be y is equal to 1, which means we're moving our graph up 1 unit. Okay, so all of those are going to be affected. We're going to have 3 things that we're going to have to do in our table of values to help us with our final graph. So again, back to regular standard table of values to begin, because we have sine. Okay. Okay. Amplitude, because we don't have an amplitude, our y's aren't going to be multiplied or divided by anything, so just leave that. Our period, though, we need to take all of our x values, because our period is our x-axis, and we're going to have to divide all of them by 2. Okay, so you're going to go 0, 45, 90, 135, 180. So then this should match what this is. So we go from 0 to 180 degrees in those 5 points. That's what that should match. Okay. Then we have a phase shift left 45 degrees. Remember, the phase shift is left or right, so that's going to be something else again that affects our x's. So we're going to have to subtract 45 degrees from each of these. Okay, so that's all that can be affected. So we had both our period change and our phase shift change for x's, which is the 2 things that can affect it. Amplitude is our y. We don't multiply or divide anything, but because our y, we are moving them up 1, we got to add 1 to each of these. Okay, then you read from the outside, so your points are negative 45 and 1, 0 and 2, 45 and 1, 90 and 0, 135 and 1. Okay, so read from the outside in, and you get to ignore all these 3 middle columns. Okay, so copy that out, make sure you have that, and then you can attempt your graph. So on the next slide, negative 45 and 1 you can't see, but then you go to 0 degrees and up to 2. Then we're over 45 up to 1, 90 at 0, 135 back to 1. And then again, remember, you're going to have to continue your graph. So all you're doing is adding the 45 degrees each time. So 135 plus 45 is 180, and then go back up to your max, over another 45 back down to your minimum, over 45 back down to your minimum. Sorry, back down to your equation of your axis here, over 45 down to your minimum, over 45 back to your axis of your curve. Okay, and then you're going to connect all of those dots, and you would keep going. Okay, now looking at some of your zeros, this is now your equation of your axes. Okay, what are some of your zeros now? So your zeros are now here because you've moved your graph. So technically this is not your x-axis anymore, it's up here. Okay, so you have a 0 at 45 degrees and 1, at 135 and 1. You have a maximum at 0 and 2, and then another maximum at 180 and 2. Okay, and then you have minimums at 90 and 0, and 270 and 0. Okay, so that is how you would do that. Last example. Lots going on here for this example. Okay, lots. It looks like lots of decimal, lots of fraction. We're in cosine. Okay, so we'll just piece it all together. So our amplitude 0.75 from our A factor out front. Okay, our period is going to be this half, but remember we need to factor as well. Okay, so we're going to get y is equal to 0.75 cos. Pull out that half from there, and when you pull out that half, you're actually going to multiply that 22.5 by 2. So it's going to be x plus 45 degrees. Okay, to pull that out, you're dividing. To pull it out, you have to divide by 2. So then half divided by 2 is multiplying. Okay, your period is going to be 360 degrees divided by 1/2, which is equal to 360 degrees times by 2. So it's going to be 720 is your period. Okay, so just be careful there with that math. Then you're going to move, look at your factored equation, and then you know that you're going to move left 45 degrees. We have no c value at the end, so you know your equation of your axes is just going to be y equals 0. Okay, so lots happening again there. Remember, this x's don't change for cosine because we're with a cosine, but remember that our y's do, so you're going to go 1, 0, negative 1, 0, back up to 1 for our graph. Okay, so you can do that. So let's start with our amplitude. Our amplitude affects our y's because it's going to stretch us up or down. So we're going to multiply each of these by 0.75. Okay, our period is our affecting our x-axis. So we're going to actually have to multiply each of these by 2. Okay, so 0, 180, 360, 540, 720. So remember, when you do that, it should match. You got your period with 720, 0 to 720. All those points should fit in between that. Okay. And then because we're moving left 45 degrees, we're going to have to subtract 45 from our x's as well. Okay, so your final points, and then equation of axes normally would add or subtract whatever that number is, but since it's 0, it won't affect the rest of our y's, okay? So you have negative 45 and 0.75, 135, 0, 315, negative 0.75, 495, and 0, and 675, and 0.75. Sorry, my pen is now not working for some reason. Okay, so those are your new points. So make sure you copy this table out and copy out your points, and then you can start to graph. So when you graph, you should get, remember that this is 0, so 0 and 1, because we're compressing our graph a bit. So this would be like 0.25, 0.5, and then this line is 0.75 here at those points. So just be careful there when graphing, okay? So you're going over negative 45 degrees and up to 0.75, 135 at 0, 315, negative 0.75, 495 back up to 0, and then 675 up to 0.75. You have 2 maximums right now. You have to graph a couple more. So you're just going from 135 to 315. So you're going up by what? Going up by 180. Sorry, I had to do math there. I wasn't quick at thinking there. Okay, so then you're just going to go 675 plus another 180 is 855. So then back down to your equation, your axes, and then 855 plus another 180 would be 1035, and down to your minimum again. So then you can get some x-intercepts, and you can get your equation, or your maximums and your minimums on equation of your axes. Okay, so some of your zeros, 135 and 0, and 495 and 0. Maximum would be negative 45 and 0.75, and then another maximum 675 and 0.75, and then a minimum 315 and negative 0.75, and then a 1035 and negative 0.75. Okay, so those are our 4 examples. Make sure you have them copied out. Okay, so you're going to work on page 34, number 1 to 9 and 10 to 16, and it says to verify answers with Desmos. So make sure that your graphs look like what Desmos does. Again, it's easy enough to say that you can plug in something on Desmos. Okay, however, you need to make sure that you can graph them, because you'll have to graph for your assignment and for your test. Okay, on your assignment tomorrow, you will be asked to do what this is. So I'll give you an equation. You'll be asked the amplitude, period, phase shift equation of your axes, and then to graph it. Okay, so make sure that you are knowing how to graph it. You have graph paper that you're using, and you're being neat. Okay, I'll show you quickly here for Desmos and what it looks like. So when you're verifying on Desmos, just type in desmos.com, and then usually graphing calculator comes up. Okay, and then you would just type your equation in. So if you go to your first equation, y equals 3 divided by 2 sine x. Oh, we had 4x, sorry. That is what it looks like, and then you can zoom in on your graph to make sure that your equations were correct. Okay, so just work with that. Ask me if you have any questions with Desmos graphing calculator, but it's just a verification. Okay, so that's what you need to do for that. Okay, so good luck. Let me know if you have any questions.